right, here we go. Everything crammed into one unit. Parabolas, hyperbolas, ellipses, what did I forget? Circles. So now, you learn things one at a time. Now you've got to like figure out what the heck they are, then manipulate them, then use the proper formulas for each shape. So enough of me blah blah blah, let's go. 10.1.5, identifying and graphing conic sections. So here we go. For the following equations, apply everything you've learned in Unit 10 to determine which conic it is, include any and all key information, and graph them. Like, whoa. So, I'm going to give you some big old hints. What needs to drive the machine is you identifying what is squared. So you look at those and you think, hey, all right, both of them are squared. So in a nutshell, we got this kind of thing in the back of our head. Parabolas can be either y equals ax squared or x equals ay squared, where one of the two variables is squared. Ellipses. Well, maybe I should have went with a circle first. A circle, because it's so simple, is just x squared plus y squared equals r squared. Notice both of these are positive. Notice what we got here, a positive one and a negative one. So now we'll talk about an ellipse. An ellipse, when you're done, is x squared over a squared plus y squared over b squared equals 1. These can be flipped here, but just for now we'll stop there. Notice both things are squared and there's a positive. Then we've got this crazy world of hyperbolas where you've got x squared over a squared minus y squared over b squared equals 1. And we could flip those by going like this. And all of this is significant, but generally speaking, you've got to have this floating around in your mind so you know how to get started. So if we look at the green stuff, I've got my positive y squared stuff, negative. You know what that's telling us? It's a hyperbola. What does that mean? Eventually it's got to equal 1. So there's a lot of clues going on. So what I'm going to do is I'm going to subtract the 284, and see what happens. I am also going to take out a 25. This is where completing the square comes into play. So I get y squared plus 8y plus space minus, now we need that minus in the problem because we know it's a hyperbola. So I'm just going to now concentrate on this, and I'm going to take out a 4, and I'm left with x squared. Now in order for this to be a negative, in order for this to be a positive with a negative in front, this needs to be minus 4x, and then plus space. This gets a little weird, but negative 284 plus space plus space. So let's watch. So, someone might have said, well, why don't we divide by 25? Well, you can see that's going to clean that up, mess that up, mess that up. So it's not time to do that yet. How about we divide by 4? Mess that up, clean that up, probably clean that up, but you got to have everything clean up. So watch what happens. Take half, 4, square it, 16. Now, 25 times 16 is 400. Is that right? Hold on, I don't want to screw that up on my first problem. 25 times 16, 400. So if I add 400 to that side, I got to add 400 to that side. Keep it balanced. Half of negative 4 is negative 2, squared is 4, but negative 4 times 4 is negative 16, so I got to go negative 16 here. I want you guys to notice something. This plus this is negative 300 plus 400 is 100. Now I'm going to rewrite this a little differently because the reason we did that is to see where our center of our hyperbola was shifted. So y plus 4 squared minus 4 x minus 2 squared equals 100. Now that we've done all that, now remember what we said, it's got to equal 1. Tells us to divide by 100, divide by 100, divide by 100. Well, this turns into 1/4, or y plus 4 squared over 4 minus, this is 1 over 25, so x minus 2 over 25, that's squared, easy to forget that, equals 1. And guess what? Now we're ready to graph this thing. Well, the center is going to be 2 to the right, 1, 2, 4 down, 1, 2, 3, 4. So essentially, there is our new x-axis and our y-axis. We're going to build on that. So now, this is a squared. Why? Because it's first. So a squared is 4, so a is 2, which means from here I need to go up the y-axis 2, down the y-axis 2. Remember what that is. It's good to label that. That's 2, -4. That's our center. Now we got to say that's b squared, so b squared is 25, so b is 5. So we go 1, 2, 3, 4, 5. We're building our box because we know it's a hyperbola. 1, 2, 3, 4, 5. Here's our box. Oh, I missed it. Go through like that, like that, like that. This is going to be very, very messy. And there we go. Now we have a decision to make. Because this starts with a y, it's going to be Pac-Man gobbling up our y-axis, which makes this the vertex. So it goes like this, and like this. And this one goes like that, and like that. Those are our asymptotes. All right. Make sure that's not blurry for you guys. All right, but what about this? Find all key information. Remember, there's foci in here somewhere. We got to find C. So we know from our hyperbola formula, running out of space, it's a squared plus b squared equals c squared. Here's my a squared, 4. Here's my b squared, 25. So that's 29 equals c squared. So if I take the square root, that's how far up I got to go from my center and how far down. So that -4, which I don't know if you can see anymore, I got expressed that I'm going up from -4 this distance and down from the -4 that distance. So my foci would be 2, -4 plus or minus the square root of 29. And that's going to be up in here somewhere and down there somewhere. All right. Let's go on to example 2. Something jumps out at me. Look at this. We got a 3x squared and a 3y squared. That means it's probably going to be an ellipse or a circle. I'm leaning towards a circle because we have perfect balance with the coefficients. Now, remember, the circle can equal something other than 1. That'll be our radius. But let's go ahead and get that 27 over there. We'll deal with that in a minute. 3x squared minus 18x minus 12, minus plus 3y squared minus 12y equals -27. Now, what are we going to do with this? Well, again, this is why we taught so much on completing the square. This has to be a 1, so we take a 3 out. X squared minus 6x plus space. Take this 3 out. Y squared minus 4y plus space equals -27 plus space. Half of that's -3 squared is 9, but we added 27 to this side, so we got to add 27 to that side. Half of -4 is -2, squared is 4. 3 times 4 is 12, so we added 12 to this side, so we got to add 12 to that side. Notice these two things cancel, so I'm going to clean this thing up. I'm going to get 3 times x minus 3 squared plus 3 times y minus 2 squared equals 12. Now, we have to decide, is this a circle or is this an ellipse? Well, because these are perfectly balanced, it's going to be a circle. And if we divide everything by 3 right now, watch how this thing cleans itself up. So x minus 3 squared plus y minus 2 squared equals 4. So here we go. Where's the center? 1, 2, 3. and then up 2. There's the new center. This is my r squared, so if r squared is 4, then r is 2. So I go up 2, left 2, down 2, right 2. And there's my circle. There it is. That's it. Let's look at number 3. You can notice my y is not squared, my x is. That means this is going to be a y equals ax squared kind, which means it's a parabola. It's like, we got to isolate our y. So subtract 7, add 6x, subtract 3x squared. And do the same thing over here. So subtract 3x squared, add 6x, subtract 7. We get y equals negative 3x squared plus 6x minus 7. Now what do? I got to look at this because this is where I'm going to complete my square. Remember, this has to be a 1. So I have no choice but to take that negative 3 out. So I left with x squared minus 2x plus space minus 7 plus space. Notice they're on the same side, which means whatever I put here, I got to put the opposite here. Half of negative 2 is negative 1. Squared is 1. But don't put a negative 1 here, because we got negative 3 times 1, which is negative 3. So I got to keep that balanced by putting a positive 3. So this turns into negative 3 x minus 1 squared minus 4. So here comes the graphing part. So where is that darn well, first of all, what does this even look like? Well, this is a y equals ax squared kind, but this is down. So right 1 from this, down 4. 1, 2, 3, 4. Went. Now, all the important information. We got to find the focus. We got to find the directrix, which means we need to know C. Now this could get messy, but we know the formula A equals 1 over 4C. Now this is going to be a really weird problem. I don't know if I made this up and made a mistake, or if I copied it from the book and they just wanted to give you a really challenging one, but there's something weird's going to happen. So be prepared. So, vertex, 1 to the right, down 4. We know because it's negative, it's going to be like that, which means, oh, and by the way, it should have been narrower, because that's going to be a vertical stretch. Should have been skinnier, but we're not worried about that. We're just trying to find these pieces. Well, it does say graph, so we better be a little more accurate than that. So 3 would be quite skinny, actually. Okay? That's probably still not even skinny enough, but we got to find C from this formula. So remember, when I plug this A in, I'm trying to find C. C is the distance, so I can ignore that negative. So I go 3 equals 1 over 4C. Now you guys haven't seen one like this, so I'm going to have to give you a quick little lesson. So first of all, 2/3 equals 4/6. And if I asked you, how do you know that? You'd say, well, if you reduce this, you'd get that. Some people would say, well, you multiply that by 2, you'd get that. But I'm going to show you something else. If fractions are equal, so are their cross products. 4 times 3 equals 2 times 6. We're going to use this to solve this, because that's really 3 over 1. Now we have equal fractions. Cross multiply, I get 12C. Cross multiply, I get 1. So C is 1/12. So that is very small. So I need to go 1/12 the way up from here, which is a really weird problem, but oh well. So that's a horizontal line, y equals negative 1, 2, 3, and I know I went 1/12 up from there, so negative 3 and 11/12 would be my directrix, or soil. And then I have to go just down from there 1/12, which is so important to understand that my vertex was 1, negative 4. I need to go down from negative 4 1/12. So that point right there would be 1, negative 4, and 1/12. There you go. Weird. That was just a weird one. All right, one more problem, and we are done with Unit 10, so let's go. Look at it. Squared, squared. These are different, and they're both positive, which is telling us, hey, it's an ellipse. So let's stick with the program. We're going to take that constant over to the side. I'm going to go ahead and get busy on this and factor a 16 out, plus space. Take a 5 out, x squared plus 4x plus space equals 84 negative plus space plus space. All right, now let's get to work. Half of 6 is 3, squared is 9. 9 times 16 is 144, so I got to add 144 over here. Half of 4 is 2, 2 squared is 4, 4 times 5 is 20. So this is 164 minus 84, which is positive 80. Now I'm going to clean this side up. 16 times y plus 3 squared. You guys should be getting better at this. X plus 2 squared. Now we said it was an ellipse. What does that mean? It has to equal 1, which tells me I got to divide by 80, divide by 80, divide by 80. And these are handmade to work. So just got to understand that. So this reduces to 1/5. So y plus 3 squared over 5. This is 1/16. So that's x plus 2 squared over 16 equals 1. We have identified it as an ellipse. The center is going to be -2 down 3. 1, 2, 1, 2, 3. There's the new center. And again, I like to draw in a new XY axis. Just helps my brain. Identify your center. That's huge. -2, -3, because things are going to hang on that. Well, 16 is bigger than 5. So that's my a squared. A squared is 16, so a is 4. What does that mean? I got to travel along the x distance 4 units. So 1, 2, 3, 4. There's my vertice. 1, 2, 3, 4. There's the other one. I didn't make them very similar, so I apologize for that. B squared is 5. Take the square root. Now we know the square root of 4 is 2. So we're going to guess that this is approximately 2.1, maybe 2.2. Anyways, we're going to go up 2.2, right about there, down 2.2, so 1, 2, just a little smidge further. And again, I made these too wide, so it's going to look pretty wonky. But this is supposed to be the same as this. So, yeah. Anyways, should have looked a lot better, but yeah, I messed up my units here. These are a lot skinnier, and so it's out of proportion. Now where's the foci? The foci are on my major axis, which is right here. So remember my center. Now I got to go a squared minus b squared equals c squared. A squared is the bigger one, so 16 minus 5 equals c squared. 11 equals c squared, so take the square root. It means I need to move left the square root of 11 from here, and right the square root of 11 from here. So that means we need to adjust our x. So our foci are going to be -2 plus or minus the square root of 11, -3. There they are. All right. Not a whole lot of problems, it doesn't look, but it's got part A, B, C, D, so they're going to make you work. So good luck, and I think you guys are ready to rock and roll. If you like the video and you want to make me viral math teacher, like and subscribe. Thank you, Ryan Shepard, for that hint.